Hi, good day everyone. Welcome to this first section of the elemental estimation, going through the examples. I'm going to go through Appendix 3, and we're going to look at the component and cost analysis method. It's going to be broken up into a couple of videos so that we can go through the methods and how you need to approach your elemental task that you need to submit in November. So that's basically what we're going to explain throughout this video. So this first one, we're going to look at how to do your how just to understand the example when we go through it. Okay, so let's look at the example Appendix 3 that has been shared with you already. Once you open it, you will see it will have its cover pages, detailed estimation methods. So this last bit of the module will focus mostly on the bill of quantities and the elemental estimate. So as I've mentioned before, the elemental estimate will focus, you won't write any tests or anything on it, but the main thing is this will enable you to actually do your task. So I'm going to go through the example. Previously we had a bit more of a detailed example, but I found that it just became too much for the students actually to comprehend how everything fits into each other. So I thought, and I've done it last year, we started with it just focusing on this example as a much easier way of just looking at the elemental estimate, and you will see now as I go through it, the principle stays the same with each of the items. You need to have your elemental guide that you use as a tick box as you go through your measurements, and you basically just develop your Excel spreadsheet or whatever program you can use, although Excel is usually the easiest way in doing the elemental estimates. We use WinQS for that. Just it makes life much easier because your measurements is linked to your DMX program. So but for our purposes it's easier just to use the Excel spreadsheet and set it up as per the example. What I'll also do is I'll share a blank spreadsheet for you so that you don't have to start from scratch. Although I'm not going to fill in everything because while you developing your spreadsheet, you will find that you will learn how everything fits into each other as you go through that process. So what we're going to look at is the elemental guide to estimation. So this is the official one that you can buy from the Association of Quantity Surveyors, and it's as the name says, it's a guideline only. So many QSs actually have developed their own method of elemental estimation. It's basically just tweaking it here and there to get to the best results out of their own experience. So as I mentioned, it's just a guide, although what we've done, or what I've done, is I shared a document with you which is freely available on the internet, which is exactly the same as the elemental estimation, which is just published by the Association of African Quantity Surveyors. I'll just show you guys how that works as well. If it does permit me, I'll quickly put that example on. Okay, just going to it's not this one. Here we go. Okay, so I'm just going to put that on the screen. So this is how that document looks. It's the guideline to elemental estimation, and you will see if any of you do have access to the one published by the South African Council, or not Council, Association. You will see that the content is exactly the same. So you can go through this. It also has a guideline similar to what we're going through now, on how to use the guideline and the purpose of it, and so forth. But you can just go through that if you need some additional information on it. Okay, so I'm just going to switch back to our example. So here we go. So here's our example. Okay, and our drawings. So I'm just going to switch to our drawings. Okay, so here's the drawing. So you will see it's a very basic two-room house, elemental, or a very basic house to measure, just to make life easier. But we still have our standard items like our strip footings, and then our basic fittings. We'll get to that area a little bit later on. Okay, so you can see what the finishes are, and so on. So it's a corrugated sheet iron roof cover. It's with here they still speak about asbestos board, barge board. So, but it's still just normal barge boards. And then still asbestos windowsills. These days you've got that precast perforated, or not perforated, but the concrete sills that you can buy in the store. Okay, so the drawing is very straightforward, and nothing funny there. Okay, and then it has a very simple door and window schedule. Also, all the windows are the same, and then just with the one or one standard type of door. Okay, so this section is fairly straightforward. Okay, so just switching back to our example. Here we go. Scrolling through the drawings. Okay, then you will see the example actually starts with the dims, or the dimensions, and this is how the QS is usually measured by hand. In the olden days we used to measure like this. These days we measure everything electronically, and we have on WinQS we've got our dim sheets where we measure in a similar way than we've got here. So I'm just going to go through this so that you can understand how the measurements actually work. And yeah, so I'll show you. Hopefully I can highlight. Here we go. So I've got my highlighter, and we'll go through everything now. So whenever you see you will see that we've got our dim paper available here, and we've got certain rules in how the measurements are done. So what usually happens here is you do your measurement on your dim sheets, and those dimensions can be used in multiple areas. For instance, if you measure the length of your brickwork, you can use it for your plaster. If you times it with your height, you can easily get your plaster area. If you measure, for instance, your window openings, you can use that dimensions again for your openings in your in your brickwork, and etc, etc. So the main thing is, this is just a place where you can do your measurements so that you can make up collections and actually take that over to your elemental estimate. You can even take these dimensions over to your bills of quantities later on, and that's why what makes it very nice if you do it in this way, although you don't have to worry too much about it. Okay, so whenever you're doing your measurements, what you want to do is you want to try and group them together. So the best method that I found is to actually build the house from the ground upwards, and you will see that your bowl structures and everything is also structured in a similar way. So you will see your concrete footings, 800 by 300 millimeters high, including excavations 1.3 meters deep, etc. So basically what we're measuring here is the length of your strip footings, and what it does, if you what you will see is here we've got two dimensions, so 10.66. So if we go to our drawing, we've got our I'll just put on the highlight again. Okay, here we go. So that 10.66 is the first one that we've got from this side up to that side, and we've got two of them, so that's times 2. So if you go to your dimension here, you will see there's a 2, and this little item there that looks like a divider item actually, or symbol, is in this instance a times. So you will see you've got your 10.66 times 2, and you will see there's a little line underneath that, so that just means that this is one item. So all of these items are added together to get to that point there. If there's no line in between, it means that the 10.66 should be times with the 5 to get to your dimension. Okay, so but we're measuring in length, so there's no timesing with height or breadth or anything like that. Okay, so that's your first length that you've measured. So, and then you have your second measurement is 5 meters. So if we go back to the drawing, you will see we've got 5 meters that's measured there, and you will see why is it not the 5.44. It's because if you zoom in here, you already measured that little section there. Sorry, the highlighter doesn't really zoom in very much. So but what you've done is you've actually measured from this end to this end already. So your 220 wall already includes that little section from there to there. So your next dimension will be excluding that little 220 wall that's over there. Okay, so that's your length, and that's why the 5 meters is used and not the 5.44. Okay, good. So that's your second dimension, the 5 meters there. Okay, and then you've got an additional 5 meters there. The additional 5 meters is just the internal wall. If we go here, it's basically this wall here. Okay, so it's that length there. So that is your excavations that you're going to have. I just wonder if they actually showed it here on the drawing. They didn't show it here. That wall should have a excavation as well. Some of your designs might not necessarily allow for the internal walls to have a foundation. Sometimes the easiest way these days that they do is they just design a thicker surface bed so that you can actually construct a 110 wall on top of that surface bed, so you don't have to worry about foundations for that internal wall. Okay, so that's more or less how the measurement works, and then you will see there's some additional calculations here. External walls, internal walls, brick wall is 1,000 millimeters, and your footings is 300 millimeters. So this is just to get whenever you do your measurement and you need to transfer it to your cube measurement, you can actually see what the depth is, and when you take it over to your bill of quantities, you times it with this 1.3. So let me just go to our drawing. So it's this, I'm talking about the 1 meter excavations below natural ground, and then just the 300 millimeters for your strip footing as well. Okay, so whenever you do your measurement in your bills of quantities, your excavations will be in cubes and not in meters like what we're measuring now. Then you will times it with your total length, that's 36 meters that you measured, times 800 mils times your height. So it's always length times your breadth times your height. That's usually the way to stagger it. It just makes life easy whenever someone else takes up your measurement. Okay, so that's more or less how the measurement works. Let me just do another one before I go to any further examples. So the brick wall, you will see again they did the measurement here. Just note that they've done the measurement in 1 meter brick wall, so you differentiate between your one brick wall and your 110 millimeter wall. So it's just the outside walls that they've used here. Okay, and then external walls that you can see, here's a little note that it's only for external walls. Okay, so that's more or less how that works. And here's the one brick wall. Okay, and this one is a little bit has a different height. It seems like it's a one brick wall in the middle and not a 110 as I thought. Yeah, you can see 100. It's also a 220 wall that they've installed here in the middle. So the main thing is just the different heights. So the one is a bit higher than the other one as well. Okay, let me just see if they've got the gable ends in here. Where's the gable ends? Hardcore. Okay, so here's just all the other items that they've measured: surface beds, hardcore, etc. Okay, this is the primary items. Okay, in this instance they just measured the length and allowed probably for the gable ends in separately a little bit later on. Okay, so this is just for your so this is just for in foundations. That's why the gable ends is not measured yet. You will see a little bit later on where it's measured. Okay, so you've got your components, rocks. Okay, so here's your hard rock excavation and soft rock excavation. You don't necessarily have to measure this. It's just a repetition of the previous, but basically your hard rock we usually allow 5%, and for our soft rock, okay, they didn't allow soft rock, but if you want to allow for soft rock, it's usually a 10% that you just allow. It's just an allowance for any unforeseen hard rock or soft rock that you may encounter on site. Okay, so that's more or less how the measurement works. I just want to get to a dimension where it's not just length that we're measuring. Okay, so let's get into our top structure. So here's our ground floor construction. Our ground floor construction is measured in square meter. So what we've got here is our 10.66 times our 5.44. So that's just the total length times breadth to get to a square meter of 57.99. So in this instance, in our elemental estimates, we usually just round it up to the nearest figure, so you will use 58 in your elemental estimate. Okay, let me see if I can get a cube. Okay, so elemental external envelope. Okay, so in here again, here is our gable walls, and here you can see where they actually applied the trigonometry to it, and you will see here some certain deductions. So you've got your different wall lengths times the different heights. Okay, so the external walls are 2.7 meters high. Here you will see a 0.026, which is your brick filling. That's the section between where your roof truss actually lays on you on your there it goes. So where the truss actually lays on top of your brickwork, that filling in between is called your brick filling. So then that is the 0.26, and you will see on your drawing you only have two sides which has brick filling, which is this side over here. Okay, so that is how they did that. And then you will see here's the calculation for the gable end. So you will see there's two little stripes, and there's the description for your gable end or gable wall, and they calculated that the height of your gable wall is 1.86 meters, and so that's your height there. And then if you use your formula is half of your height times 5.44, and you've got two of them on either side. Okay, then what they've done here, they've calculated all of these items. So what will happen in this case is all of these square meter areas is then added up to get to 99, and then you will see they've done a deduction for your doors. So here's your two doors, and here's your 4 windows that they've deducted from that. Okay, so that is basically how they calculated the area. Okay, so here's the deduction, and here's the final square meter for your external walls. 1 brick walls. Okay, then now we've got a 220 wall for our internal wall. So this actually shows that in the foundation we had a 220 wall, and then in our top structure we have a 110 millimeter wall, and you will see that we've got our beam filling here that they've measured, and you get your total area there. Okay, then we've got the component external finishes. Okay, so your external finishes, we've got plaster walls. So what you can do is you can use all of these dimensions and times it with your internal walls and gable end trimmings. Okay, for now I'm going to stop it here for our first video. The next video will take it further from here, because I just want to get you into the swing of things. So this is more or less how the measurements work. So if you go through this example, you will see how the certain components are measured.